Hello everyone, my name is Marcus Williams. I'm a software engineer at Intel Corporation. I'm going to be presenting today on the progress of the Open Daylight community, and it has to do with S3P, which we call, well, I'll say that here in a second, but essentially it's scale, stability, security, and performance. So the Open Daylight community has made tremendous progress over the last year. We started with relatively little to measure Open Daylight's effects on S3P metrics. I started working on S3P and measuring Open Daylight about a year and a half ago. Our first tests were decidedly simple and based on previously available software, things like Cbench, and which has its own limitations that I won't go into. But we soon realized that focusing on interfaces, sort of the tests that Cbench does, interface metrics and things of that sort, were short-sighted because it provides information in a vacuum. Essentially, you're not going to understand your actual performance if you leave out the complex pieces that are needed for your use cases. I'll talk more about that evolution next, but we also sort of realized that available tools did not provide the information needed to characterize S3P metrics. So we created custom tools. We did some complex, we put some complex testing scenarios together and automated as much of this work as possible. We also took a chance to sometimes chastise and other times encourage internal Open Daylight projects to become involved in envisioning, creating, and interpreting the S3P tests that, and the metrics that we want to use in this group. And I will say that, I think I'll touch on it later, but there's a small group that's called the STP Workgroup inside of Open Daylight that works on this in particular. So over the last year, the community has produced 2 Open Daylight performance white papers, and many of the tests included in this white paper have not been upstream and automated as of yet, but we're working towards that goal. So the progression of S3P testing focus. I've talked previously about S3P at Open Daylight Summer, ONS 2016, ODL Developer Forum. Over time, how we talk about this problem has changed inside the Open Daylight community and how we want to actually create the tests. The first discussions were very interface and component based. The issue with focusing on interfaces or specific components, it excludes other pieces that have large impacts on recorded S3P metrics. Next, we focused on use case-based metrics. This switch was a vast improvement, but it's vast improvement over focusing solely on the interfaces. But it allowed us, our first glimpse of how ODL might perform in a real situation. But oftentimes, to talk about or accomplish these use cases, we were emulating base components. We were emulating base components in the setup and leaving out the heavy machinery that made a use case work. We moved to what I like to call full stack metrics, or use case plus full software stack. The analogy would be moving from Mininet and OpenFlow plugin to OVSDB, NetVert, OpenFlow, Neutron Northbound, and OpenStack in a specific use case. So in other words, you're involving all the different pieces that you might want to work well in your S3P use case, and you're measuring with all of those things rather than just some emulation software and a very small component of that. And the culmination of this transition was the ODL Performance White Paper, so Open Daylight Performance White Paper, we released the first paper on May 14, 2016. Each test run in the white paper and each result listed comprised a stack of software needed to facilitate each use case. Specific instructions to set up the use case. It provided instructions to reproduce each test, and provided some numbers of other SDN controllers for comparison. On June 6th, we released an updated version of that and updated the versions of the controllers used and some testing methodology. Our 2.0 report, which is something that we're working on right now, we're likely to release at ODL Boron SR1, which should be around October 27th or next month, about a month from now. If you're interested in actually reading the prior performance reports, obviously there's a link here at the bottom that you can check out, ODL performance. And I think you'll get the 1.1 report, which is an updated version of 1.0, but it should have more information about what we found 6 months ago. I guess not quite 6 months ago. Some of the lessons we learned from the ODO performance report. First, the performance between open source SDN controllers is roughly comparable, at least as we found when we tested in, I guess it was May. Complexity of platform increases with complexity of increases the complexity of the testing. When I was talking earlier about full stack use cases, one of the reasons we don't have a performance report to report on right at this moment is because when you increase the complexity of the software stack you're using, it takes much longer to get a valid test, to create it, to automate it, and put it in a place that will allow you to actually use the results. So creating our first report provided some pointers on how to do future reports. So we should reduce the effort it takes to actually do the reports. We should automate as much as possible upstream, and then we pull those tests down maybe at the time of a report to generate a report at each release rather than have to create everything from scratch each time we did the report. And oftentimes when we put data out there about what a certain metric about what was happening, it's best to do sort of a in context, or talk about what's happening in context, and I think that we could do a better job at that. So the plans for 2.0 or Open Daylight Performance Report. First of all, we're updating some of our processes, what we're doing. So we're thinking more along the lines of single factor variation. That's as opposed to testing against other controllers. We might test earlier versions of Open Daylight. We might test changes in environment or changes in setup, and then compare the results, analyze the results to see what we're getting there. Obviously, I've talked about this multiple times already, but develop upstream and add to public cloud automation. So we want to push those tests upstream, have people have eyes on them, and make it easier for people to pull them down and test them locally if they want to reproduce the tests, which is actually part of the next, create portable test scripts. We use something in ODL called Robot. You might have heard, if you were listening to Luis earlier, that we use it in all of our CI. And you can run it locally. So if you pull down the tests using Git and run them locally, give it the right environmental variables, you can run all these tests on a local setup. So we want to make sure that we create portable tests that are easy to do that with. In the future, we want to do more work on creating an easier consumable report. So whether that's visuals and graphs, things that allow you to sort of compare what this might do to your network. So in the past, I think it was very academic, sort of the way that we were describing things, and we think we could do a better job of describing it for people who want to use it to understand how it actually affects their network. As far as additional test focus for the plans for 2.0, we want to focus on cluster, number one. We have some OpenFlow cluster tests that are upstream right now, but there are many other pieces and plugins inside Open Daylight that we need to add cluster testing to for S3P. And I'll tell you the reason why we don't have those tests right now. In general, functionality testing is still in process. So adding those functional tests that allow you to make sure that things are working correctly in certain plugins and certain communities, those have to come first before we can actually do the performance or scale or stability testing on the plugin. And since those are in progress still, in some cases, we can't really do the work we want to do. Additional test focus, NetVert, that's something that we're actively working on right now. We have some tests that we're looking at doing scale with OVS by itself and creating networks and ports and various things to test how NetVert works by itself. And then we also have tests that we're working on where you have OpenStack compute nodes. And those compute nodes, those compute nodes will be arrayed, and then we'll run Rally against the compute nodes and get information about how creating networks and adding VMs to those networks and working through that process, getting numbers back, running Rally with those things happening in the setup. We also will focus on stability and longevity tests. And if you want more information about the planning of this test report, at the bottom here you'll see a wiki link and that's where we keep all of our documents for the STP Workgroup. So you can check that out if you would like to. So I talked about this a fair amount already, that we want to upstream and automate tests. And the reason I've done this is in the past, our first report, we didn't have tests upstream. Most of the tests run upstream. And we had to create wiki docs to allow people to reproduce them and download special sort of hack together things that we had created to run the tests locally. So it became a little difficult because people had to go to this wiki page, walk through all the steps and pull down the things, and then run the tests themselves. What we'd like to do, and what we've been doing, and I'll talk more about this in the next slide, but when we put these tests upstream and we add them into Jenkins, which runs them periodically, and we use Robot to automate them, and then we make as I said before, you use environmental variables and you can run them locally. It allows better source management, so you can go and comment on these tests before they get upstream. It also allows reproducibility, which I've already beat to death a little bit, so I won't talk much more about that. But regression management is something that you can use as well. So, for example, in Jenkins, you can see when something has regressed in order to, like say if you update your code, you have this test running periodically, you see a drop in some performance metric or scale metric, and then you can go and say, what did we do on that commit? And then go back and fix those problems, file a bug. I would say that we wouldn't want to use these upstream tests as the cardinal numbers of what OpenDaylight's capable of doing because of the limitations of the VMs that are there. And this might be a good time to actually go to the next slide, which talks a little bit about what tests are upstream and what the VMs actually show you. So the controller VM that we have upstream, and Luis might have touched on this like it's right before me, but essentially we usually run a VM with 8 cores, 8 gigs of RAM, Java 18091, and the VM's running on OpenStack. It's connected via internal switch. So all the tests run with this sort of a setup. And that's what I was saying a second ago, that this will limit the actual performance of OpenDaylight because you're limited to 8 gigs of RAM and 8 cores and so on. So we wouldn't want to use these numbers necessarily as the performance numbers that we share with others, that this is what OpenDaylight can do. I will say that these are tests that are currently upstream that we've taken from the original report we did, and we've automated those tests and we pushed them upstream. And so I won't go through each one of them, but you can see there's a bevy of OpenFlow tests that tends to be the most heavily tested and developed on plugin that we have. It includes 100K flows, REST setup, 64 flows distributed in 32 switches, so on and so forth. We also have a couple netconf and BGP PSEP tests that are upstream as well, which are it's sort of a nascent work that I'm sure will be added to because we had more of those tests in the performance report than our upstream. I will show you one slide here, which is an example of what you'll see in Jenkins upstream when these tests are run. So this is the OpenFlow CSIT one node periodic REST comp performance daily. This is a very recent test that Luis added to this setup, and it basically shows you what's happening on each of these different runs, how performance is changing, configuring the data store, configuring the flows in the OVS switch, and then configuring the operational data store to match whatever the switch's configuration is set up to do. So these are all upstream, and as you can see, having something like this is very useful, but also being able to run it, as I said before, and reproduce it locally is also really useful, which will allow us to easily produce performance numbers in the future. I don't think I have too much more to say about this slide here. So what's next? Well, we have to complete some in-progress tests that we're working on in the STP Workgroup. Those include sort of the tests here at the bottom, NetVert one node OVS scale, NetVert one node OpenStack compute node scale, NetVert one node OpenStack compute node performance, and then there's various clustered tests that we still need to add to. We're hoping that the 2.0 version of the report will actually have a lot more clustering information than previous versions, or the previous version, I guess. So we're going to expand that cluster testing. We also need to expand what we're testing in S3P, so that includes creating new use cases and finding sort of new ways to look at the sort of issues that OpenDaylight is going to solve in people's networks and figure out how do we measure that helpfully and give that information to the community. One of the other projects that's kind of in progress is creating an S3P dashboard, which will sort of show these numbers all in one place in a way that's consumable easily. And we'll also show you if there are regressions really quickly. Virtual bridge domain and FDIO is something that we'll probably look at in the future. And there's been a lot of questions I've been receiving recently about the server-side control plane. That says plan, but I mean it's a plane for S3P. So what is happening on the control side when you're on the server, whether it's OVS or FDIO or some other, I guess, server-side control plane application. So that's sort of what's next, and for the performance report in the S3P Workgroup. But also, we have the workgroup, and I'd like to share sort of we meet at 8:30 on Friday morning. At least a few people in the crowd who get up for this meeting, and so they know that, yeah, it's a fun time we have together. But this is basically the wiki page if people are interested in learning more information or being a part of the S3P workgroup. Yeah, we can definitely use more help, because most of the people who are working on this are working part-time. They have other full-time jobs and other projects, developing features and doing other things. So more resources would always be helpful. So I encourage you to come and visit this website, join us on our call. We also work pretty closely, and a lot of the people who are involved in the S3P workgroup are also involved in CPERF project, which is an OPNFV project, control performance testing. And the idea is to create an industry standard performance and scale tests for SDN controllers and continuously reproduce those based on the new versions that are upstream. Not upstream, but the new sort of artifacts that come out from OpenDaylight, other controllers, and then with the stack that OpenFE already wants to use, and sort of their use cases, so on. So most of the people involved in this are involved in that. I'd encourage you to go and look at this website as well, and we could also join us on those calls, which are on, I believe they're on Thursday at 11:15 a.m. Pacific time. Both of these are in Pacific time. Yeah, PST, yeah. So thank you, and I'm happy to take questions. Obviously, we're about a month away from releasing the second performance report, so there's not as much to share about actual data, but any questions?
So I got one. So it's like this. So I met a lot of those like testing case outside, testing report outside. So one problem I see is that some of them have different settings.
Some of them have different settings?
Yeah, so I can see that if you have like different settings, like some is right, some is wrong, the result can be different. So
yeah, that's definitely true, depending on what you, so I'll go back briefly to the lessons we learned in the performance report. I didn't really go through these, but these boxes in the bottom are slides from a previous presentation I gave on the performance report itself. And one of the lessons is coordinating environments and procedures and configs across different labs and across testing is a problematic thing. And we found that one of the things that really affects performance is the persisting of data in the config data store. So what OpenDaylight can do is persist that data and store it on the disk. A lot of other controllers, by default, they keep that in memory. We can turn that on and off, and so what we found is that we were getting quite quite bad numbers until we turned off data persistence in the config data store. And so configuration can have a huge impact on what numbers you're getting, depending on what you're doing. Yeah. So I'm not sure.
So do you think like ODL, they have like guideline or something?
What's that?
So ODL, do ODL have like, when you do this testing, do you have like a guideline?
Oh, a guideline. Yeah, I mean, in general, we have, yeah, we actually do have a guideline. In general, we make sure that everyone's sort of testing with the same, let me see if I can find a quick, if if I can show you. Maybe I'll just look at the, yeah, basically when you have instructions to rerun these tests, they talk about the things you need to do in order to get the similar performance that you're seeing. I'll see if I can find the slide that might have. This isn't exactly but if you look at this testing, test case 1 northbound rest benchmark, right above there, it'll talk about your local config, it'll talk about how you configure OpenDaylight, it'll talk about how you configure other things in order to make sure that you're getting performances commensurate with what you're being reported on this test. So
another way to address that, or that we are addressing that, is by, and Mark has touched on this at various points, but to hammer it home, we want to move away from sort of those one-off white papers that people go off in their labs and use certain configurations and certain sets of hardware and make sort of this one-time result. We want to move from that model more towards test and CI that are output to a dashboard, and you can do continuously updated stuff that we don't have to do this monolithic report effort on, just as part of the general testing. So that would standardize the configuration based on how we do the deployments in our CI environment, and the infrastructure based on the infrastructure that we're deploying against in our CI environment.
Right.
So I think that's probably how we're going to end up solving this.
Yeah, I think for ODL side, like you can, all people right now doing the comparison.
But external people?
Yeah. So
Yeah, they just need to come work upstream with us.
yeah, it's a good call. Yeah, I think what Daniel says is right. In general, we want to move towards automating and upstreaming everything. And even the pulling down and running the tests locally and sort of reporting on those results, if we can move that into cPerf at some point where it deploys onto real servers, runs these tests, and gets sort of the higher level benchmark. So by that I mean you're not limited by your resources. Like I was saying before, some of these tests run upstream. If you have 8 cores and 8 gigs of RAM, it might limit how the controller performs. But in the cPerf environment, you have 5 servers and you can configure them however you want. They all have a standard hardware configuration, but we can get by that problem by running those tests there and then having that available for people. So, yeah.
Are you also doing any stress tests, like driving system into overload? Are you planning to do stuff like that, basically to see how it behaves?
Yeah, I mean, we don't have those. We don't have many of those tests. We have some longevity tests that are sort of upstream. We don't have many stress tests. It's definitely something we talk about and on the list of things that we want to do. It's just a matter of there's other priorities that we're fulfilling right now. But
I guess it depends on what we mean by stress tests. I mean, there's longevity tests or formal stress tests. There's tests that add switches and batches of 100 or something, and then sees what the maximum sort of breaking value is there.
Yeah, that's what I mean. Like, basically find out that kind of configuration, what's the value that actually breaks. I mean, to see that the next release can decrease or it performs better.
We definitely have scale tests that do just that. The idea is to figure out what's the limit and so on. Like a long-running sort of bombarding the controller with a lot of data, a lot of packets or something like that. I don't think we have anything sort of like that, but yeah.
I mean, that's basically what the longevity test is, right? It just adds switches and removes switches constantly for 24 hours.
Yeah, but if you had sort of an active network and you're pushing packets through those switches and there's packet ins generated and a bunch of other things, you're going to see a lot more stress on the controller. So,
one of the tests
yeah.
that we're building in cPerf uses MT bench as a traffic generator and has other northbound things. So it's a more realistic traffic environment, basically. So if we finish that test and get it running in OpenFE and then run it for a long period of time, that would be a pretty good result, I think, in that space.
Yeah, agreed. Any other questions? I'll just, there's maybe a minute or so left. One of a couple of the tests we're doing right now have to do with NetVert, which is recently split into its own project in OpenDaylight. And let me see if I can find it. Oh yeah. So we're looking at testing this in a couple different ways for scale-wise and with OVS versus sort of the full compute node scale. One of the things we're doing in our lab is sort of setting up OpenStack inside containers. and spinning out a bunch of those containers so that you have a multitude of compute nodes. And I think we're up to like 200 at this point. We're just trying to validate that we have a working OpenStack setup, that we can spin up VMs, do things of that sort. And then it's pretty straightforward to run a rally against that, which spins up a bunch of networks and does some interesting things and reports out what time it takes to do all those things. The problem I think we're going to have in the future is we're going to have to expand those rally tests so that they actually add VMs, because there's an interesting thing that happens with OpenDaylight when you're using OVSDB and NetVert and other things. If you set up the network in the config data store, it'll add certain flows into the switch at the beginning, but until you add VMs, a lot of the traffic that you see is not going to happen. So if you're just testing, sort of adding networks to OpenDaylight, adding networks to OpenStack, but not actually having any VMs on those networks, then you're not going to have sort of the full impact of what will happen in that scenario. So as soon as we get that worked out, we're hopeful to scale up past 500 nodes, 600 nodes, and run these rally tests where we add VMs and get numbers back. But that's in progress, and we're not exactly sure when it's going to be finished, but yeah, definitely working. So, okay, well, thank you, everyone.